It's really fascinating, isn't it? We see these huge leaps in AI, incredible potential.
Absolutely.
But actually getting those tools into, the hands of doctors, the people on the front lines, that still seems like a big challenge.
It really is, especially in fields like ophthalmology.
Exactly. Think about ophthalmology, those retinal images, CFP, OCT, they hold so much information. Keys to spotting diseases early, diseases that can, well, steal someone's sight.
Crucial information.
But asking a busy clinician, hey, can you retrain this complex AI model, or expecting them to understand all the deep tech stuff?
That's just not realistic most of the time. It's a big ask.
Right. And then you add in the difficulties of sharing sensitive patient data between different places.
The data sharing hurdle, yep. Plus, adapting models to different equipment, different populations.
And this isn't a small problem we're talking about. Globally, I mean, think about diabetic retinopathy, macular degeneration, glaucoma. The numbers are huge.
Staggering numbers. And early, accurate diagnosis using those imaging techniques, CFP, OCT, it's absolutely vital on a massive scale.
You've really hit the nail on the head. The potential of AI in eye care is immense. But yeah, those practical hurdles you mentioned, they're what we need to figure out to see real widespread impact.
Definitely. The need for specialized AI know-how, the difficulty adapting models, those have been major roadblocks, no question.
Well, that brings us neatly to today's deep dive. We're going to zero in on GlobeReady. It's a new AI platform specifically for diagnosing eye diseases.
Ah, okay. GlobeReady.
And what caught my eye, what seems really exciting, is its claim to be truly clinician-friendly. It aims to kind of sidestep those usual technical barriers.
Okay, that's a bold claim. Clinician-friendly is the holy grail in medical AI, isn't it?
It really is. So our mission today is to dig into how GlobeReady supposedly pulls this off. How does it offer a solution that doesn't demand an AI degree to use effectively? We're basing this on a pretty detailed research paper that lays out its development and testing.
Right. And from what the paper suggests, it's not just a one-trick pony.
Yeah.
It seems to cover core diagnosis, adapting to local clinics, even telling you how confident it is.
And finding similar past cases, too.
Right. Case retrieval. And crucially, all of this apparently without needing clinicians to write code or run complicated training cycles.
Exactly. Sounds almost too good to be true sometimes. So let's jump right in. How does it work? Let's start with those core diagnostic abilities. They call it GlobeFree.
GlobeReady.
The idea is it works straight away. No retraining, no coding needed for basic diagnosis. How does that stack up in testing?
Well, the paper presents some pretty compelling data. Let's take the JLH-W11 dataset first.
Yeah.
That uses color fundus photos, CFPs, and covers 11 different eye conditions.
Okay.
On that, GlobeReady hit a top 1 accuracy of 93.9%.
Wow. Okay. So nearly 94 times out of 100, it got the main diagnosis right on the first guess.
Exactly. And if you look at its top 3 guesses, the accuracy climbs to 97.6%. And for top 5, it's up to 98.5%. Really strong performance.
Those are impressive numbers. But accuracy is one thing. What about making sure it doesn't miss cases? The paper mentioned recall rates too, right?
Good point. Accuracy tells you how often it's right overall, but recall tells you how well it finds all the cases of a specific disease.
Right.
And the top 1 recall was also strong at 91.6%, with similar high rates for top 3 and top 5.
Okay.
What's also interesting is the range. Looking across all 11 conditions, the top 5 recall varied, but it was always between a solid 88.2% and an almost perfect 99.9%.
So it's consistently good across different types of problems. Macular issues, optic nerve, retinal vessels.
Yeah, it seems quite robust across those different categories covered in the dataset. Macular diseases, optic nerve head-related ones, vascular problems, and other retinal conditions.
And this wasn't just for the fundus photos, the CFPs. They tested it on OCT scans as well.
Correct. They use another dataset, JSAKE OCT15. That one has OCT scans covering 15 different eye conditions.
And the results there.
Still very solid. Top 1 accuracy was 87.2%.
Okay.
Top 3 was 90.9%, and top 5 reached 92.7%. The average recall was in a similar ballpark. And again, looking at the range for top 5 recall across those 15 OCT conditions, the lowest was still around 71.8%, going up to 99.5% for others.
So the takeaway from this GlobeFree part is that it establishes a really strong diagnostic baseline, works with both main imaging types, and handles a wide variety of diseases.
That seems to be the conclusion, yes.
Yeah.
A strong starting point without needing that initial setup hassle.
Okay, that's a great foundation. But as we mentioned earlier, this domain shift problem is a big one in healthcare AI.
Huge.
A model works great in the lab or on the data it was trained on, but then you take it to a different hospital, maybe with different scanners, different patient ethnicity.
Different disease prevalence.
Right, and suddenly performance drops. Usually that means retraining, which takes time, data, expertise. How does GlobeReady handle this adaptation challenge?
Okay, this is where it gets quite innovative, I think. They use something called local retrieval augmentation.
Local retrieval augmentation. Sounds technical.
It does, but the concept is actually quite neat. They took inspiration from Arger retrieval augmented generation, which is a hot topic in large language models right now.
Ah, okay. Like giving the AI access to external knowledge.
Sort of, yeah.
Yeah.
But here, instead of retraining the whole core model, GlobeReady enhances its existing features using a small amount of local data from the specific clinic or setting where it's being used.
So it's like giving the AI a quick local orientation, showing it this is what things look like around here, without making it relearn everything.
That's a great analogy, yes.
Yeah.
It extracts key features from, say, a few dozen local images from Clinic X using Scanner Y and uses those features to augment the general knowledge the base model already has. It fine-tunes its understanding for that specific context.
Without needing a full retraining cycle.
Exactly. And the paper shows this approach, yielding some really significant improvements when they tested it across different places.
Oh, yeah. Where did they see this working?
Well, first in China, across 3 different hospitals, GJEH, QCH, PNH, they saw performance go up with this local augmentation. But the jumps were even more dramatic when they tested it internationally. In Singapore, using the SEED dataset, which is notable for its multi-ethnic population.
Right. Important for generalizability.
The top 1 to top 5 accuracies improved significantly, reaching a range of 73.4% to 91.0%. And these weren't just small bumps. They were statistically significant improvements, meaning unlikely to be just chance.
Wow, that's quite a boost. Any other locations?
Yes, in Vietnam, at the Binh Dinh Eye Hospital, or BDEH. There, the accuracies went from a baseline of around 51-73% without augmentation, up to 86.3, 96.9% with it. Again, highly significant statistically.
That's a massive difference.
It really is. And they saw similar positive results in the UK using a diabetic retinopathy screening dataset called UKDR, where accuracies hit the 90.2, 98.9% range.
And this worked for OCT images, too, not just the fundus photos.
Yep, same principle applied to OCT. They tested it on the WAEH OCT13 dataset from Wuhan, and also on data from Zeiss OCT machines, the Zeiss OCT11 dataset. In both cases, significant increases in accuracy and recall rates after applying the local feature augmentation. For the WAEH data, accuracies went from 81 and 89% up to 89, 92.5%. For the Zeiss data, it jumped from 61, 77% up to 83, 95%.
Okay, so this local augmentation thing seems like the real deal for tackling domain shift. It lets the AI tune into the local specifics without needing AI specialists on site to do heavy lifting.
Precisely. It feels like a very practical solution to that adaptation problem, making the tool much more usable across diverse real-world settings. It bridges that gap.
Now let's switch gears slightly. Trust. In medicine, trusting the AI's output is absolutely paramount. Doctors need to know how reliable a suggestion is, right?
Couldn't agree more. A black box diagnosis isn't very helpful in a clinical context. You need some sense of confidence.
So how does GlobeReady tackle this? How does it provide that confidence level?
They've integrated Bayesian methods, specifically something called Monte Carlo dropout. They call this version Bayesian GlobeReady.
Bayesian GlobeReady, okay. Monte Carlo dropout. Sounds complex again.
Yeah, the name's a bit much. But think of it like this. The AI doesn't just make one prediction. It makes the prediction multiple times. But each time it randomly drops out or ignores some of its internal connections.
Okay.
By doing this repeatedly and seeing how much the predictions vary, the system can estimate its own uncertainty. If the predictions are very consistent despite the dropouts, it's confident. If they vary a lot, it's less confident.
Ah, I see. So it's not just giving the diagnosis, it's also saying, and here's how sure I am about this diagnosis.
Exactly that. And interestingly, adding this layer of confidence quantification actually improved the diagnostic performance itself.
Really? How so?
When they applied this Bayesian approach to the JLHW11 fundus dataset, the top 1 accuracy nudged up from 93.9% to 94.9%.
Okay, a slight improvement.
And the top 1 recall also improved significantly. They saw similar statistically significant gains on the JSEG OCT15 dataset too. Top 1 accuracy went from 87.2% to 88.2%, and recall improved as well.
But they didn't stop there, did they? They used this confidence score in another way.
Right. This is quite clever. They set a confidence threshold. If the AI's confidence for a particular case fell below that threshold,
It flags it.
exactly, it flags the case, basically saying, I'm not entirely sure about this one. Maybe a human expert should take a closer look.
Like a safety net.
Precisely. And the impact of implementing this threshold was dramatic.
Yeah, dramatic.
On the JLHW and fundus data, using this threshold to refer uncertain cases pushed the top one accuracy up to 99.4%.
99.4.
Yep. And the recall hit 98.5%. Massive jumps and statistically significant.
Wow. And for the OCT data?
Similar story.
Yeah.
Top one accuracy went up to 96.2% and recall reached 94.5%. Again, highly significant improvements just by having this mechanism to filter out the uncertain cases for review.
That's incredible. It really shows the power of not just predicting, but knowing when you don't know.
Absolutely. And the paper mentions they compared GlobeReady, even without fine-tuning, to other big foundation models like Retrieval and Vision FM that had been fine-tuned for specific tasks.
And how did it compare?
GlobeReady actually came out ahead on the top 3, top 5, and these confidence thresholded metrics.
Without needing extra fine-tuning.
Without needing extra fine-tuning, according to their results. It highlights the strength of their core pre-training and this Bayesian confidence approach.
Okay, so the ability to provide a diagnosis, estimate certainty, and flag tricky cases for human review, that sounds incredibly valuable for actual clinical use. It builds that trust.
It really does.
Yeah.
It lets clinicians leverage the AI's speed and accuracy while keeping human oversight right where it's needed most.
Okay, let's think about another real-world challenge. Clinics inevitably encounter rare diseases or conditions the AI just hasn't been trained on. What happens then? Does GlobeReady just try to force it into a known category?
That's a critical question. You don't want the AI confidently misdiagnosing something completely new.
Right.
So GlobeReady incorporates what they call open set anomaly detection. It's designed to recognize when something looks unfamiliar, like an out-of-distribution case.
Anomaly detection. How did they test that?
They created 2 new data sets specifically for this. One called CFPO-D49, that's 49 new fundus disease categories the AI hadn't seen,
Okay.
and another called OCTO-D13, with 13 new OCT conditions.
And could GlobeReady spot these as being new or different?
It seems so, yes. On the CFTO-D49 fundus set, it did a pretty good job identifying these novel cases as anomalies. The detection rates varied by condition, naturally.
Any standouts?
Yeah, for some conditions like choroidal osteoma and MEWDS, it had perfect 100% detection. For most others, the rates were strong, typically in the 85–95% range. Even for epiretinal membrane, the most common new condition in that set, it hit 90.2%.
Any conditions it struggled with?
They noted a lower rate for peripheral retinopathy, but they think that was mainly because they had very few examples of it in the test set.
Fair enough. Small sample sizes are always tricky.
Crucially, it was also good at spotting low-quality fundus images, detected those 94.6% of the time, which is important, right? Garbage in, garbage out.
Definitely need to flag poor quality scans. What about the unfamiliar OCT images?
Similar story on the OCTOD13 dataset. Perfect 100% detection for Stargardt disease and optic disc pit maculopathy.
Wow.
Really high rates, over 94% for things like silicone oil in the eye, PIC, and choroidal hemangioma.
And others.
Moderate to high rates, around 83–88% for conditions like CRVO, focal choroidal excavation, and vitreoretinal lymphoma. And again, it was good with quality control, detecting low-quality OCT scans 92.8% of the time.
So it has this built-in, this looks weird detector.
Essentially, yes. It doesn't just blindly try to classify everything. It can flag things that fall outside its known categories, which acts as a really important safety net.
Yeah, that seems vital. Okay, moving beyond just diagnosis and flagging unknowns, what about using AI to find similar past cases? That seems super useful for learning or dealing with rare stuff.
Oh, definitely. Being able to quickly pull up examples of similar presentations could be incredibly helpful for clinicians. GlobeReady aims to do this with its feature-based case retrieval.
Feature-based, meaning it looks for similar visual patterns.
Exactly. It uses the underlying features the AI has learned to find images in a database that look visually similar to the current case, even if it hasn't been explicitly trained on that specific case type for retrieval. And again, no retraining needed for this function.
How well did this work in their tests?
They tried a couple of things. First, they took 168 fundus photos from Vietnam and tried to find matches within a combined database of known conditions, plus those 49 new ones.
Right.
The ability to find the single best match, the top one recall, varied quite a bit by disease. It was highest for things like epiretinal membrane and sunset glow fundus.
Okay.
But Interestingly, even for rarer conditions where the top one match wasn't perfect, the system often found highly relevant cases within the top 3 or top 10 results retrieved.
That makes sense. Maybe the absolute closest isn't quite right, but seeing a few very similar ones is still super informative.
Precisely. Then they did a more clinical evaluation. They got 3 ophthalmologists involved.
Oh.
They used those same 168 Vietnam fundus photos, but this time searched against a huge database, over 747,000 unlabeled fundus images.
Wow, a massive search space.
Yeah, and they asked the ophthalmologist to rate the relevance of the top 10 cases GlobeReady retrieved for each query image.
And what did the docs think?
Well, the average accuracy for the single top one retrieved case based on the doctor's judgment was 52.2%.
Okay, about half the time.
But look what happens when you consider more results. The average accuracy for the top 3 retrieved cases jumped to 71.4%.
Better.
Top 5 was 79.2%. And for the top 10 retrieved cases, the relevance accuracy hit 90.1%.
Ah, okay. So while you might need to look beyond the very first result sometimes, the system is consistently bringing back a set of really relevant examples within that top group.
Exactly. It's effectively narrowing down that huge database to a small, useful set for clinical review. And they saw even better performance with OCT retrieval.
Oh, yeah.
They used 150 query OCTs against a database of over 34,000 unlabeled scans. The top one retrieved case had an average accuracy of 92.0%.
92% for the top hit. That's strong.
Very strong. And it climbed even higher for top 3, 98.4%, top 5, 99.3%, and essentially perfect for top 10, 99.6%.
So the case retrieval for OCT seems particularly effective.
It does, yeah. Suggests it's really good at matching those complex layered structures in OCT scans.
This feature alone sounds like it could be a game changer for handling complex or unusual cases, or even just for education.
I agree. A powerful tool for clinical support and learning.
Now, all these features sound great technically, but for any tool to be truly clinician-friendly, it has to be usable, right? Fit into the workflow, feel intuitive. Did they get feedback from actual ophthalmologists using it?
They did, yes. They conducted a questionnaire evaluation with 7 ophthalmologists, a mix of residents and more experienced consultants.
And what was the verdict?
Overwhelmingly positive, it seems. They use a 1 to 5 rating scale.
All right.
Average score for usability, how easy it was to use, was 4.5 out of 5.
Pretty good.
Effectiveness in helping with diagnosis, also 4.5. Support for clinical decision-making, 4.5 again.
Consistent. What about the confidence scores? Did they find those helpful?
Apparently so. The usefulness of the confidence scores got an average rating of 4.6.
Even better. And the interface itself, like how clear was it?
Interface clarity and the guidance provided got a 4.7 average.
Wow. High marks across the board. What about overall satisfaction? Would they use it again or recommend it?
Yep. Strong scores there too. Recommending it to colleagues got a 4.4, and their willingness to continue using it themselves was 4.7.
That's really compelling feedback, isn't it? Because you can have the smartest AI in the world, but if doctors don't find it practical or easy to work with,
It just won't get adopted. Exactly. This suggests they've really thought about the user experience, which is crucial for getting AI tools into routine clinical practice.
it's encouraging to see that focus. Finally, just briefly, did they shed any light on how the AI is achieving these results? Like, what is it actually seeing in the images?
Yeah, they did a little bit of looking under the hood using a visualization technique called AGF visualization. They analyzed the model's pre-trained weights, its internal learned parameters.
To see what it learned.
Essentially, yes. And they found that the model had intrinsically learned to focus on the disease-specific features in the images without being explicitly told to.
For example,
Like for fundus photos, it would pay more attention to the macula area when looking for AMD signs, or the optic disc for glaucoma clues, or the blood vessels for vascular issues like BRVO.
so it learned the relevant anatomy.
It seems so. And similarly, for OCT scans, the visualization showed it was focusing precisely on the pathological changes within the specific retinal layers affected by different diseases.
That's fascinating. It wasn't just finding random correlations. It learned to zero in on the clinically significant parts of the image.
Exactly. Which provides some solid evidence for why its feature matching and diagnostic performance is so robust. It's learned to see what matters.
And just to recap the underlying tech quickly, what went into building this? Massive data sets.
Yeah, they started with a huge collection, hundreds of thousands of real CFPs and OCTs, covering over 400 diseases from diverse sources.
Okay.
And then they used AI, specifically something called fundus scan, to generate millions more synthetic images to bulk up the training data even further.
Using synthetic data, too. Interesting. And the core AI methods.
2 main pre-training techniques mentioned were Dyno V2, That's a self-supervised method they used on the synthetic data to learn general visual features.
Mm.
And CLIP, which uses contrastive learning on real image-text pairs to help the AI connect visual features with their medical meanings or descriptions.
And it's this combination that gives it that ready-to-go diagnostic
As
ability.
the idea, yes. That extensive pre-training is key to the coding and training-free deployment. Plus, the Bayesian Monte Carlo dropout for confidence we talked about.
Right.
And they used a statistical method, Uden's index, to figure out the best confidence threshold for flagging those uncertain cases.
So a pretty sophisticated blend of data and AI techniques.
Definitely. A lot went into building this platform, clearly aiming to address those practical clinical needs.
Okay, so let's try and wrap this up. GlobeReady seems to present a really compelling package, doesn't it? High accuracy out of the box, this clever local adaptation feature, confidence scores, anomaly detection, useful case retrieval.
And all wrapped in an interface that clinicians seem to find genuinely usable and helpful.
It really feels like it tackles that tricky trade-off between power and accessibility that holds back so much medical AI.
I think that's a fair assessment based on this research, yeah. It makes a strong case for lowering the barriers to entry for powerful ophthalmic AI.
Now, of course, no research is perfect. The paper itself mentioned limitations, right? Areas for future work.
Absolutely. They acknowledge things like potential class imbalance in the training data, needing finer control over the synthetic image generation, maybe needing to calibrate the confidence thresholds differently for screening versus diagnosis, and wanting to improve that top one accuracy for case retrieval further. All valid points for ongoing development.
And they had ideas for tackling those.
Yeah, they mentioned exploring newer generative models like text-guided diffusion, refining the threshold strategies, improving the retrieval algorithms, and just continuing to expand the diversity and coverage of their training data. Standard, but important, next steps.
Good to see they're aware of areas to improve.
Always a good sign.
So as we finish this deep dive, it really makes you wonder, doesn't it? If platforms like GlobeReady become more widespread, how could that fundamentally change eye care globally?
That's a big thought.
Think about it reducing the need for specialized AI teams in every clinic, potentially making this level of diagnostic support accessible in more resource-limited settings.
The potential for wider reach is huge.
What new possibilities does that open up for catching diseases earlier, for managing patients better, maybe even for accelerating clinical research by having this kind of data analysis readily available? It's definitely something to think about.